to now, the engine has been the heart of the car. It had to be big and strong with lots of horsepower and cylinders. Now with the electric drive, several things change. The heart of the electric car is the battery. It determines simple but essential things such as the driving range. And it also determines to some degree how eco-friendly the electric car is, which raw materials and how much energy is used to manufacture the battery. So where are we heading with battery development? Which technologies will win in the end? And are we on the road to the super battery? 3 of the most renowned battery experts will now discuss this topic with us. So let me introduce them to you. First, I'll start with Frank Blome, sitting on the stage here in Berlin next to me. Hi, Frank.
Hi.
Frank heads the battery cell business unit at Volkswagen Group Components, and before joining Volkswagen in 2018, he held management roles at Continental, Automotive and Lithium Battery. Really good to have you here on stage.
Thank you very much.
And then joining us online is, first I'll start going to Sweden, Swedish national Peter Karlsson. He's the CEO of battery manufacturer Northvolt and Volkswagen's strategic partner for battery cell production in Sweden. And of course, you just met our battery expert, Professor Maximilian Fichtner, just a few moments ago. Good morning again, Maximilian Fichtner.
Good morning.
So, let's start talking about the future of the batteries. Now, Frank, let me ask you, well, many people, when we look at the media, they expect batteries to become better. We just heard from Maximilian Fichtner. Yes, they're already pretty cost effective. We've seen a cost reduction over time. They also want them to become greener. So let's start with battery performance, range, and charging time. What are the potentials that you see at this moment?
Well, for the range, of course, there are different technologies already in place. There are different technology ongoing in the future. I think so far we have made it to a good point. We have cars can be used even on long distance driving. But the future cell technology like solid state will bring more range into the car, will come with fast charging. We have also other technologies and I think we can reduce the charging time to a half in the next years. And this will bring a much better car for the customers.
And I mean, we're already at a really amazing point in time. We talk about the future, but just yesterday we saw the world premiere of the ID.4 GTX, and it's just amazing fact when you look at these vehicles. So when we look at today's state-of-the-art cell technology, and we talk a lot about lithium ions naturally, do you think that will go away eventually when the solid state is market ready, or will we see coexistence of several types of technologies?
Lithium is probably a long-term solution, but today's lithium technology has a complex cathode, complex anode, electrolyte that can all be developed into solid state, into better anodes and cathode technology. And with that, we can reduce the price. We can increase the energy density by at least 30%. And again, charging time will go down dramatically in the next years.
And you just had your Power Day, also Volkswagen Power Day, where you explained a little bit about the closed loop, which was very interesting. Now, all of this is also not possible without partners, especially strategic partners, to help Volkswagen in its endeavors. So, Peter, well, I can imagine you're pretty busy these days working, because you said you want to produce the greenest batteries in the world. So tell us, what exactly does that mean?
Well, what it means is that battery manufacturing is incredibly energy intensive, specifically if you include the whole value chain. And you saw a little bit earlier in the presentation about the raw materials processing, the active material, and the cell manufacturing. Which means that to produce 1 kilowatt hour of a battery cell, you could consume over 100 times the amount of energy in that process. Which means that it becomes very, very important how we build the supply chains around supporting the car industry to transform with batteries. If we take the global production of vehicles, which is roughly 90 million vehicles a year, and we basically say that these will all be supplied by batteries at certain point, let's say in 10, 15 years from now, then if we're building that in coal-based and grids like the China grid and also some Eastern Europe grids that we have, we're basically building a carbon footprint half the size of Germany in building solutions to the current problem with oil and gas. But and what we are trying to prove here that is building these supply chains in a sustainable way, building it with hydropower, we can do it in a different way, and thereby we can build significantly lower carbon footprint batteries, and thereby achieving a much better solution on the problem we're trying to solve, which is the climate crisis.
So can you give us a little more detail? I mean, you just briefly mentioned the coal power grid. So what exactly is then the difference between a battery produced with coal electricity and one produced, like you said, with water energy, renewables especially?
So the difference is if we take most of the batteries on the market today, the active material that goes into those batteries are being produced in China, such as graphite and the cathode material. These are heavy processed. It's a heavy process industry. Requires a lot of energy. Is driven by coal and natural gas. And thereby, since they consume so much energy, they are also then creating a large carbon footprint in their manufacturing of these batteries. What we're doing up in Skellefteå is that we're supplying all our different manufacturing processes with electricity from hydropower. So instead of coal, natural gas, or any, we are using hydropower and electricity, and thereby is minimizing the carbon footprint. And obviously this has a huge impact on the carbon footprint of the battery cell.
And that sounds really wonderful. And like you just said, I mean, as Volkswagen does it, Salzgitter, you are also building this gigafactory in Sweden. But what are the challenges involving doing this? You just talked about the supply chain. I can imagine there are quite a few challenges in just pulling this off and being completely renewable in the process.
I mean, there are significant challenges. I mean, we're kind of pioneering building these types of factories in Europe, which means that not only do we need to design and find good partners around the key elements of the factory, the equipment, how to build it, etc., but it also means that we need to build supply chains around. A lot of the raw materials and components are today having a majority of its infrastructure in Asia, so we need to bring these supply chains to Europe. And not at least, this is a new type of manufacturing, which means that we need to train a lot of people into the operators, the process engineering roles. There's a large competence gap in Europe at current stage. And this is going to be one of the biggest challenges for the growth of the industry, how fast we can train, learn, and educate a skilled workforce into this. And just for our factory up in the north, over the next 4 years, we anticipate we need to bring in roughly 3,000 to 3,500 skilled operators. And this is high-tech manufacturing, so it's not for everybody. It takes at least a year in training to get operators up and running. So if you ask me, the biggest challenge is that competence development and bringing that skills up.
Yeah, and as you said, there's no blueprint for building such a gigafactory. Now, we talked about the production, manufacturing batteries. Let's talk about the other part, the recycling. So you also do recycle the batteries in Sweden. What are the methods that you use for that? And is there a connection to Volkswagen's closed loop concept?
Yeah, no, I mean, we recognize that since we are doing the integration of the active material in our manufacturing, it gave us also a unique opportunity to build a closed loop system where where we have developed together with two universities, one in Sweden and one in Finland. We developed a method where we're crushing the batteries, but then we're using a hydrometallurgical method to separate the raw materials. And we have achieved recycling levels in our pilot plant in Västerås that is actually over 90% right now in our pilot. And we are also able to recycle lithium, which is a significant step forward. Most of the processes so far that has been developed for recycling has been focused on using pyro, using a furnace and melt down the material to recycle it. But here we actually have a process that we think is even better in recycling more of the materials of the battery. And we are right now developing partnerships. We are developing pilots with Volkswagen around how we can work together. With Volkswagen, we have also developed a joint venture in Norway with Hydro, where Norway is a big market already for electric vehicles, so that we can start getting feeds. Ultimately, we aim to build a 4 gigawatt-hour recycling plant in late 2022 up in Skellefteå, in order to start getting feeds of recycled material, and thereby reduces our need of active or mined prime material.
Wow, ambitious plans. Good luck for that. Now, Maximilian, let me ask you, we hear a lot about the lithium-ion technologies, and then we talk about solid state as the next step. But then every now and then in the media we hear about alleged super batteries announced by some startups. They sometimes even win prizes for it. So as a scientist, a researcher, what's your opinion? Are there any realistic concepts that you see, anything that interests you that is realistic for the near future?
Actually, I'm always happy when I read these news. But what you can find is that quite often only one certain aspect of a battery is addressed by the startup. And this is, of course, strongly advertised, and they want to take that as a selling point. However, I mean, if you are in a while in that business, then you know that there are many other aspects which can play a role, and this is often not discussed in such newsletters or whatsoever. And I would therefore recommend to just wait a little bit and see what comes out of this technology. Sometimes it's obvious that they have overlooked something. Sometimes these are startups which come from a different technology, which have no experience in battery technology, read some numbers in literature and think that they are the only relevant ones, and then they target at them, and then eventually they fail because they have overlooked something. This has happened very often, and there are also startups, I don't know whether you can still call them startups, which have been quite successful, which have been respecting all these important parameters. And I would say QuantumScape is certainly one of them. They are on a good track for realization of a solid-state battery. I have not seen data from industrial scale and format battery from QuantumScape, but what I saw from the I would say the small cells, this already looks quite good. But now it's a big challenge to scale that up and make a factory out of that. And then there are other startups which have grown tremendously, like CATL and others, which are going to change the battery world because they have new battery concepts. They invented this cell-to-pack technology where you can integrate much more active material, and this is fantastic. This gives us much more perspectives for the future.
And probably also inspirations, right? What are the relevant upcoming battery technologies in your opinion? Is it going to be solid state batteries, nanotechnologies? Do you think we can expect some sort of a revolution at some point, or is it going to be an evolution?
I think the revolution has already started by a few things, like on the engineering part, just mentioned cell-to-pack technology enables much higher degree of freedom for selecting the materials. I mean, we had mentioned the lithium iron phosphate. Lithium iron phosphate was actually ruled out as a potential car material in a car battery. But now, because you can just integrate much more in the battery, it certainly comes back because it has fantastic properties. It's a more or less sustainable option. It is safe. It runs for millions of kilometers. This is fantastic. But also in the current technology, I mean, we are now looking at upcoming anodes, which have much higher capacity than the previous ones by the integration of silicon. This gives another boost, and I would expect that this enables us to build batteries which are far beyond the 500 kilometers driving range.
Frank, let me also ask you the same question. How do you see that from Volkswagen's standpoint? What do you see as the relevant technologies for Volkswagen in the near future?
Yeah, I totally agree to what we heard before from Professor Fichtner and Peter. I think to make the technology greener makes a lot of sense. I don't think it's only the energy supply, it's also development into less energy into the production chain. The cost is very much important to make sure we can scale up and sell the vehicles to even more people. And we are working on that, and we see big potentials there. And for the technology, there is a lot of resources, intelligent engineers, chemistries, and also money in the game supporting all these developments. And we see a big push in the market every year with new technologies. As said, not all the startups will make it, but some do. And companies like Northvolt are going in the right direction too, to make sure the CO2 consumption is on the best level.
And there must be a reason you have a strategic partnership with them. So
probably.
We talked about manufacturing, we talked about the technologies. I just want to briefly go back to recycling, because that's what you're doing in Germany also. We heard some impressive numbers from Peter. Tell us what Volkswagen is doing in this closed loop concept and what you're doing with battery recycling.
Yeah, we built a recycling system in Salzgitter. We invested a few million euro into that. We tried to push the recycling market with that. Yeah, it was a quite old-fashioned business so far. Recycling of batteries was always profitable. So if you put your batteries in the supermarket in the green box, you don't pay for that. Yeah, there's a reason for that. So all that makes a lot of sense. Will finally even improve the business case, and of course, the energy consumption in total is much less than what it is right now.
When we look at the consumer perspective, now Volkswagen has already announced drastic reductions in battery costs are possible. We heard Ralf Brandstätter this morning. So what does it exactly mean for the price competitiveness for a consumer, an EV or a BEV, a battery electric vehicle versus an internal combustion engine? Will electric cars eventually become the most affordable choice in the market?
Yeah, I think the potential is absolutely there. So if you ask me, I will say yes. My diploma 25 years ago was an electric vehicle drive system. Yeah, I needed long to get there. But I'm a strong believer in the technology, and as said before, there was a big improvement into technology and cost, and we still see a lot of potential. We still see a lot of potential, especially in cathode materials, as Peter mentioned. This is 50% of the cell's material cost today, and there's a big potential to get this down with the next level of technology, get the expensive metals out, less expensive metals in, and find the right compromise for greener, better, and more affordable batteries.
Peter, would you agree? Is that something that you strive for, to actually, especially make the price attractiveness in the end better than it is now?
I mean, absolutely. I think, you know, with every, I mean, previously what we've seen is that a lot of the cost reductions in the batteries have come with improved energy density and improved cell chemistry. What I think we are going to see going forward is a combination where we are going to see improvements in cell chemistries, and in certain areas, you know, we're going to see really high performance battery cells, you know, over 1,000 watt-hours per liter, and maybe 1,400 watt-hours per liter. The question is if right now, if that can be combined with the cost that is required in order to reach larger segment of the market. And there, I think we, just as Frank was saying, we just need to have a holistic view and look at chemistries. We need to look at supply chains. We need to look at scale economy, and not at least, just as you mentioned, recycling will drive lower cost of raw material, because we think that it will be significantly cheaper to use a recycled battery to build a new battery than to use prime material. So I think it's all about improving all aspects of this, and as it scale, we will see the cost going down per kilowatt hour, and thereby achieving larger and larger market penetration.
And Maximilian, we've seen how the costs have been massively reduced in batteries. Do you think the same will be true eventually for hydrogen?
No, I've been working on hydrogen, and I saw that there have been many developments made in the 1990s, 2000s. I have the impression, I may be wrong, but I have the impression that these developments, which are ongoing since 60 years or so, are going to reach a saturation. I mean, you cannot go beyond some natural limits, so-called thermodynamics. And even if you get there, you would still have a cost issue, for example. And this is something where we can certainly get better. The question is how much. I mentioned in my talk that I would expect from the entire hydrogen chain to come down by a factor of 3 in the cost. That would be necessary in order to be really convincing, to be really competitive. But alone the fact that you need much more energy to drive this entire process chain is a barrier, and you cannot just overcome it.
So for the near and mid-term, hydrogen will be attractive, maybe for air travel, maybe for the huge container ships that we see, but definitely not for passenger cars.
I don't see it. It's also the question, how much green hydrogen can you produce? I mean, we have launched a big hydrogen strategy in Germany, but the amount of green hydrogen that is foreseen by this strategy is just enough to supply the German steel industry. There is nothing left for chemistry. There's nothing left for other branches. There's nothing left for cars. So actually, I don't see it at the moment. perhaps it happens, and I can be convinced, but I just don't see it at the moment.
All right, and I think you probably agree because Volkswagen's strategy is definitely the BEV for the near and midterm future. No one knows what's going to be happening in 30 years, but for now we see the battery will be the answer.
Yeah, technically it's quite simple. It's you can take the regenerative energy made of sun or of wind, put it into photovoltaic or a generator, and then load it in the battery. If you do it with whatever more complex structures like hydrogen, you have to produce a hydrogen and you lose efficiency step by step by step. So finally, to take the energy directly into electric power in the car is the shortest way and probably the best and easiest solution. And
we'll talk about charging today. We'll talk about the grid today, how actually the car becomes part of the grid, then can be integrated. So this is really, really smart. Thank you all for now. I'll just want to go to trying to answer as many of the questions from our audience as we can, because we have questions coming in. Thank you for that. So let me start with the first one. Interesting question to you, Frank. So give us a date. When will we have production of solid-state batteries?
Very difficult, very difficult. Ask me next year.
Okay.
We have a quite important milestone early next year, and we are working with different companies. But of course, we invested into QuantumScape, and we see very good progress. I would say the proof of concept of the technology is done, but to scale it up and bring it into production is really difficult. And as Professor Fichtner said, there are a few good ideas needed. Yeah, but we will know what to do early next year.
So not too distant future. So we have a question from Wilfried Eckel-Dorner. He says, Dear Peter, in 2019, Northvolt announced the factory in Sweden with a full-scale production of lithium-ion cells from 2023 onwards. Is that plan still on track, or do you plan to go full-scale production of 16 gigawatts earlier than 23?
No, so the plan is still there. Actually, already by the end of this year, we will produce the first cells out of Skellefteå. It will be C sampling towards our automotive customers. But in 2022, we will start scaling up Skellefteå, and then also in 2022 we will start the expansion of the Skellefteå plant. Right now we're building 16 gigawatt hours, but we are then in 2022 starting up the construction of an additional almost 45 gigawatt hours, so to get us up to 60 in total. And the time plan for the entire upbringing is towards 2025 because it's just such a it's a massive investments and bring up.
And there's another question relating to that from Michael Freitag, because you talked about the competence. So you mentioned the challenge to get qualified people for operating the cell plant. And that in mind, how realistic are the announcements by to build cell plants and gigafactories in Europe? I mean, we need a lot of factories. You just talked about the 60 gigawatts.
Yeah. No, and I think this is going to be one of the biggest bottlenecks going forward. We earlier thought that maybe financing is going to be one of the biggest challenge, but we now see that the whole financial market have kind of it's not they are no longer questioning whether the transition is going to happen. So we see a large transformation of capital going into this sector, which enable financing. And then you look at the next bottlenecks, which is really on the competence side, and it is also on building the supply chains in Europe to support these factories. Equipment, raw materials, components. On the competence side, There is initiatives on EU level in trying to build a transformation program to train, a large amount of new operators into this. I hope they are starting to get this running by end of this year. But it is for the next 5 years. I think this is going to be one of the most critical challenges for not just for us, but for ACC. The Total PSA endeavor to build a gigafactory. For a number of the other initiatives, the competences is an absolutely critical parameter in success here.
Frank, do you agree? Do you share the same challenges in Salzgitter?
Absolutely, yeah. So we have a large team built up in the last 3.5 years. So I have more or less 400 to 500 engineers working only on battery cells, and another 200 working on battery systems. And of course, in the Volkswagen Group, there are other teams quite large working on that. But it's a challenge. We have international team. We have, I think, 16 nations in the company in the meanwhile. We speak English every day, yeah, and we try to scale up knowledge. And as Peter said, this is a big challenge. We support each other where it makes sense. We also support our suppliers, and so they do us. And together we can build up the industry, but it's still a long way to go.
So this is a call out to all of the future engineers to get into that industry. You might have a safe place to work. So we have another question.
Absolutely. I mean, if you're interested in batteries, you have and you want to go a chemistry education or there is a whole bunch of different paths towards to sell, but you have a fantastic future. I can tell you that.
Let me try to get in one last question. Frank, this one is for you. Sean Carson asks, will we see different battery technologies for different vehicles or market segments, given the different costs? Or will the most efficient battery technology then be the most affordable due to the economies of scale, especially in the case of Volkswagen? So small BEVs will have a different battery tech to, say, maybe Project Trinity.
Yeah, good question. So the battery platforms will be done based on standards. Yeah, we just announced our unified cell system. Our suppliers really like it. It makes sure that the investment can be used long time, and the inside of the cell will be different between the different models. So LFP is a good example. We heard that before, lithium iron, and with that comes good cycling, low costs, and for the high range and big battery cars, still nickel is a good solution. Later, less nickel, more manganese is a good solution. And this will come into the market, and we will have different applications of the systems. But it's important to scale up and use synergies wherever possible. And with that, the cell format, the unified cell format, is a good move. Everybody is telling us to make sure we can really bring this on the next level.
Will be exciting to see. Peter, I have one more question for you. The question is, will Northvolt deliver its cells to the Volkswagen Group only, exclusively, or do you have other automotive customers signed up so far as well?
Yes, we will not be exclusive to Volkswagen, even though Volkswagen is both a big owner and our biggest customer. But we've already announced we have BMW, and we're gonna work with a few more in order to achieve the scale that we also think we need. And we have announced that we think that achieving somewhere around 150 gigawatt hours over the next 10 years in Europe is an objective to reach a 20-25% market share.
So you have the customers, the clients, then we can see lots more gigafactories from Northvolt, and possibly in the future also lots more gigafactories from Volkswagen. I think you have the plans, and the most important thing is that we are unified in all of this together, because it is about clean and sustainable mobility. That's where we're heading, and that's what we're going to talk about today some more. For now, thank you very much, Maximilian, Peter, and thank you, Frank, for coming here, for answering all these questions. Thank you for watching.
Dear viewers,